Hey guys, this is Sergey, and you're watching Dissecting the Code. Today I want to continue the topic that I've started in the previous episode and cover the ConfigureAwait best practices. But before that, let's recap why ConfigureAwait was added to the language in the first place. Let's say that we have a Windows Forms application that upgrades the progress bar, then gets the data from the data source, and then updates the text box. So the migration to async version is very simple. We need to change the result type from void to async task, and then we need to await an asynchronous operation. So instead of just calling getData directly, we will await getDataAsync, and that's it. In this case, the application behavior should be exactly the same. It means that if updateTextBox method invocation was called from a UI thread, the same should happen in the async version. And that requirement and the ease of migration from asynchronous code to asynchronous has an impact to this day. What it means that the code on the right should capture synchronization context and task scheduler at the beginning of a synchronous operation and run each step of a synchronous operation within those contexts. So let's recap. The synchronization context is a way to abstract the threading model away. For instance, different UI frameworks have different requirements for threading. For instance, in Windows Forms and WPF, you cannot touch UI elements from non-UI threads. So instead of dealing with that threading model directly, the synchronization context abstracts things away. So instead, you can post a message to the synchronization context to be invoked within those contexts. Another example is a classic ASP.NET. For instance, the HTTP context.card is stored within the synchronization context. And task scheduler is kind of a strategy designed to abstract away how the tasks are scheduled and executed. By default, the default task scheduler runs all the tasks in a thread pool thread. But you can create a custom task scheduler. For instance, some people do use a task scheduler to control the number of concurrently invoked tasks. Another example is Orleans, an actor-based framework that relies on task scheduler to run the grains from a single thread. So now let's look at this asynchronous method in more details. Let's say that we have an application code on the left and the library code on the right. For the code on the left, we want each step of the asynchronous operation to be executed within the synchronization context. For instance, updateTextBox should be called from the UI thread. But the requirement for the code on the right is different. So this is a reusable piece of code. And let's say that it has two stages. First, it gets the data from the database, and then it decrypts the data. And that stage is CPU intensive. So if that CPU intensive step would be running in the UI thread, then it will make the UI less responsive. So for the code on the right, we want for each step of the asynchronous operation to be run in the thread pool thread. But for the code on the left, we want each step of the asynchronous operation to be run within the synchronization context. And so ConfigureAwait is a way to tell the runtime where to run each step of the asynchronous operation. By default, it runs within the synchronization context or using a captured task scheduler. But if you annotate an asynchronous method with ConfigureAwait false, it tells the runtime to detach the synchronization context and task scheduler and to invoke each step of the asynchronous operation in a thread pool thread. So it means that for the code on the left, we should respect the synchronization context, but for the code on the right, we should detach it. And now we can come up with the general ConfigureAwait guideline. For the applications, we should not use ConfigureAwait false. We should rely on the default behavior. For applications, we have two cases. We either have synchronization context, and in this case, we should not use ConfigureAwait false because we want to respect it. Or if we don't have the synchronization context, then lack of ConfigureAwait won't change the application behavior. But for libraries, the situation is different. We don't know the context. We don't know whether the code is going to be used in an application with or without synchronization context. And in this case, we should annotate each await with ConfigureAwait false to avoid performance impact or the deadlocks that we're going to cover next. And keep in mind, if you have multiple awaits in the library code, each await should be annotated. You should not annotate only the first await with ConfigureAwait false. Technically, it's enough, but it's way better to annotate each await with ConfigureAwait false. And now let's cover what's going to happen if we use ConfigureAwait false incorrectly. So let's say that we have a library code and we don't use ConfigureAwait false. In this case, there are two main problems that might happen in your application. First, the performance degradation. Each step of a synchronous operation runs within the synchronization context. And it means that if that synchronization context runs the UI, then the UI thread will be executing CPU-intensive steps. Another one is very famous, the deadlocks. There are three requirements for the deadlock to happen. First, you should have a concurrency limiting task scheduler or synchronization context. Many people know that the UI-based synchronization context can cause deadlocks. but the same case could happen if you have a concurrency limiting task scheduler. If you configure it to have, let's say, at most 40 threads, and all of those threads will be blocked, you could have a deadlock. The second aspect is that you should have a library code that lacks ConfigureAwait false. And the third aspect is that you should block that asynchronous operation. Only having all three of these problems, the deadlock might happen. By the way, lack of ConfigureAwait false is not the only problem. Having ConfigureAwait false when you should not have it also can cause issues. This is not well covered, but it actually might cause application to crash or have various data races and whatnot. For instance, in case of the UI applications, only a dedicated thread can access UI elements, and trying accessing them from a different thread will cause invalid operation exception and application might crash. In case of classic ASP.NET, you could have null reference exceptions or stuff like that because HTTP context.current will be null, causing logical errors or just crashes of the application. And in case of concurrency limiting task scheduler or synchronization context, you might oversubscribe. And in case of Orleans, having ConfigureAwait false might cause data races. And by the way, Toub provides a similar guideline in his ConfigureAwait FAQ. Essentially, for applications, he states that we should not be using ConfigureAwait false because the default behavior is what we want. And for libraries, because the context is unknown, we should use ConfigureAwait false to detach from the synchronization context and task scheduler. And now, here are the ConfigureAwait guidelines. We should use ConfigureAwait false for highly reusable code on every await. And we should not be using ConfigureAwait false for the applications. One thing that I would highly recommend is to establish your own repo-specific rules. For instance, ASP.NET Core team decided not to use ConfigureAwait false in the entire code base because they know that ASP.NET Core itself doesn't have the synchronization context, and they don't expect their code to be used in the context where the synchronization context or task scheduler actually matters. I've seen many code bases that have ConfigureAwait false on every line, both for reusable pieces of the code base and for the applications, which doesn't make sense to me. You know the context. You know that this code is not going to be run within the synchronization context ever, so why to pollute the code base with this useless stuff? So I would highly recommend to codify those requirements using static analysis rules. For instance, there is a CA2007 to do not directly await the task. So if you have a highly reusable library, I would recommend to enforce that. But please don't enable this rule for the application code. Unfortunately, there is no built-in rule to block the usage of ConfigureAwait false in the code base. That's why I've created a rule in my error-prone project to do exactly that. You can enable this rule globally in the whole source code or in specific application folders, and then you will break the build if someone will use ConfigureAwait false where it should not be there. Some people still believe that using ConfigureAwait is some kind of a magical best practice that will avoid deadlocks in your application. But to be honest, these days, custom task schedulers or synchronization contexts are not that popular. In most cases that I've seen, the deadlocks were not related to synchronization context and ConfigureAwait false, they were caused by task completion source. Some people just blindly enabled a bunch of static analysis rules, and one of them are enforcing usage of ConfigureAwait false. And so I've seen many applications that littered with ConfigureAwait false with no good reasons. There are like official guidelines not to use ConfigureAwait false in the application code. We should stop using it there. And it's totally fine to have a static analysis rules to ban usage of ConfigureAwait false and get rid of them in the entire code bases. That's it for today, guys. Thanks for watching, be curious, and see you next time.